Right, Year 10 GCSE 2021 end of year exam, 80 marks, 90 minutes. Question 1, pie chart shows the proportions of electricity generated in UK from different energy resources. And what we've got is gas, coal, nuclear, and renewable. And the first part is to calculate the percentage of electricity generated using fossil fuels. So out of these, which is a fossil fuel? Coal is a fossil fuel, gas is a fossil fuel, nuclear is not, renewable is not either, as all fossil fuels are non-renewable. So it's 34% plus 43, which is 77%. The second part is the pie chart shows 7% of the electricity was generated using renewable energy resources. Which one of the following is not a renewable energy source? Okay, so wind, renewable, solar, renewable, oil, non-renewable. Okay, it's fossil fuels, non-renewable energy sources. Following question, complete the following sentence. In some type of power station, fossil fuels are burned to heat something to produce steam. Okay, so steam is water heated up. So inside the fossil fuel power stations, water is heated, that turns to steam, that drives turbines, which drive the generator to produce electricity. Burning fossil fuels releases carbon dioxide into the atmosphere. Why do many scientists think adding carbon dioxide to the atmosphere is harmful to the environment? There is a strong link between carbon dioxide and global warming. Okay, so carbon dioxide causes global warming, and that's what many scientists think. Question 2, polonium-210. There is the symbol with the 210 there. 84 is the number of protons. That 210 is the number of protons and neutrons. Is a radioactive isotope that decays by emitting alpha radiation, which is the correct decay equation for polonium-210 when an alpha particle is emitted. So we are looking for 210 on the left hand side. These two numbers must add up to 210. If you have a look, this number and this number add up to 210. This number and this number also add up to 210. This one, not so much. That's 218. So we can discount the first line. The bottom number is 84. 82 plus 2 should give us 84, which it does. 86 plus 2 gives us 88, and that is not the total on the left hand side. So the answer is the last one. Why is alpha radiation dangerous inside the human body? Because alpha radiation is large in mass and it knocks off electrons from atoms and molecules, causing and leading to ionization. Okay, so the figure below shows how the mass of a sample of polonium-210 changes with time. Okay, so as it's decaying, the mass of radioactive atoms decreases over time, becomes less and less radioactive. And what we've got here is the first part to determine the change in the mass of the sample between 50 and 150 days. So how much radioactive material is left when we go from 50 days. 50 days, we've got 465 grams of radioactive material. After 150 days, we have 280 milligrams of radioactive material. So how much has decreased? So that's the change. So it's 465 minus 280, which is 185 milligram change in mass of radioactive material. To estimate the mass of polonium-210 after 300 days. So 300 days is here. However, the graph does stop at 250, and we can see that the trend is relatively smooth. We can extrapolate and carry on. And we get the line ending around about 140 milligrams. If you go across there, that is around about 140 milligrams. So after 300 days, 140 milligrams of radioactive material remains. E. Complete the sentences, choose answers from the box. An atom becomes an ion when it loses. Okay, so atoms lose electrons. So an electron has to be lost. And when an electron is lost, the overall charge on the resulting ion is positive. The opposite of that would be adding electrons onto atoms, and that would make the ion negative. But losing electrons makes the ion that is left positive in charge. Question 3. The diagram shows a metal pan being used to heat water. The energy from the gas flame is transferred through to the metal by conduction. Explain the process of conduction through metals. Now, this is unique. It hasn't said through plastics or non-insulators. So metals, what makes metals a good conductor of heat? So metals have something unique about them. They have free electrons. Okay, so metals have free electrons, whereas insulators don't. Okay, thermal energy from the gas flame is transferred to the ions and free electrons as well. Okay, so these free electrons within the metal gain heat energy from the flame, and the electrons start to move faster than what they were moving at before, as they have gained kinetic energy, and these electrons collide with other electrons and ions to transfer the thermal energy across the metal.